right, 9.4 partial fraction decomposition is what it's called. So it's basically a way of rewriting a rational expression. So if I have this as my rational expression, I can rewrite it using partial fractions. And this is used in calculus all the time when you're trying to find the integral of an expression. You need to rewrite it using partial fractions. It's all you're doing is rewriting it a different way. Because if you're trying to evaluate the integral or find the antiderivative, it's called, we don't know how to do that. However, if you rewrite it, then it's more easily obtainable. All right, so here's what we do. We factor the bottom. There's going to be a lot of factoring in this section. So I have 4x minus 3 over x minus 7, x plus 2. So far, so good? Or did I lose you? These are not rhetorical questions.
Did you just do that off the top of your head?
Factor?
Yeah.
Oh my goodness. Yes, I'm amazing. Okay, so now, once we have the two factors on the bottom, we assign a to the first one, and we assign b to the second factor. Okay, and it could have been x plus 2 first and then x minus 7. It doesn't matter. You just assign a to one of them and b to the other one. Put it on top of it. All right, so that's our second step. Now, we need to multiply both sides of the equation by the denominator here. We're going to multiply both sides by x minus 7 times x plus 2. So the left side, if we multiply this times this, do you see that the x minus 7 and x plus 2 divide off, and you just get 4x minus 3? You can divide those off, you get 4x minus 3. Equals, if I distribute that here, it'll be a times x minus 7 times x plus 2. And you can notice that the x minus 7s are going to divide off. Once you distribute that, these will divide off, and I have a times x plus 2. And then if I distribute it to the last one, the x plus 2's cross off, and it'll just be b times x minus 7. So I'll review what I have done so far. We've got a rational expression. We factor the bottom. We assign a over the first factor, b over the second factor, and then we multiply both sides of the equation by this denominator right here, and this is what we get. Okay, so I'm going to get rid of the parentheses. So 4x minus 3 equals ax plus 2a plus bx minus 7b. All right, so now we get to set up a system of equations. There are numbers here or constants. There are x terms or linear terms. There are no x squareds or x cubed. So really I only need two equations. One for the number and one for the x's. So the x's, how many x's do I have? How many x's do I have on the right side? I have a plus b. This is my x coefficients. 4 equals a plus b. So now I need one for the numbers, or the constants. On the left I have negative 3, and I have 2a minus 7b. Do we know how to solve that? I sure hope so.
Perhaps.
Perhaps. Okay, so you could do it by hand or you could just matricize it. I will do that. Matrix, edit 2 by 3. Reduce row echelon of matrix A, and we're going to frac it.
I'm going to frac you.
So I get 25/9 and 11/9. Okay, so we're basically done. We just have to rewrite what we started with. We figured out what A is and what B is. And this is how we defined, this is what we're going to go back and look at. That's our A, that's our B. So it is 11, oops, A is 25/9 over x minus 7 and 11/9 over x plus 2. Now we don't usually have like a fraction inside of a fraction, so I would rewrite this finally as 25 over 9 times x minus 7 plus 11 over 9 times x plus 2. We have rewritten the original rational expression to be this. This is just it rewritten using partial fractions. All right, I want you to try one.
We have to.
Yes.
Wow.
All right, so we have 6x plus 4 over x squared minus 25. See if you can rewrite that using partial fractions. What's our first step? Cry. Factor the bottom, very good.
X plus 5 and x minus 5.
X plus 5, x minus 5, there you go. That's a difference of squares. Then put an A over each of the one of the factors and B over the other factor.
So the same thing.
Then you're going to want to multiply both sides by whatever that bottom is, x plus 5, x minus 5. I'll give you a couple minutes here. So the question is, if you're going to multiply both sides by this, which we're going to, x plus 5, x minus 5, the question was, do you always just get like A times the opposite one and then B times that opposite one? That is the case if you just have two factors. We're going to have different types of problems, so I wouldn't get into a shortcut of doing that. Here's an update of how I've done. Hopefully you're still on track. Multiply both sides by our denominator. Now you're going to have to set up a system of equation, one equation for the x's and one equation for the numbers. Alright, so I got an equation for the x's. I've got 6 x's on the left and I've got a plus b. And then the numbers, I have 4 equals negative 5a plus 5b. I put it into a matrix, reduce row echelon, and then frac it, and I get 13/5 and 17/5. So A is 13/5 and B is 17/5. So if we go back up here, 13/5. I'll write my answer. If this A is 13/5, I'm going to go 13 over 5 x plus 5. And then B is 17/5, so I'm going to go 17/5, and I have an x minus 5 on the bottom. Raise your hand if you got that. Good. For the first time ever trying this, like half the class, if not more, got it. So, very good.
Yay.
Yay! And the crowd goes wild.
And it doesn't matter if the x plus 5 or the x minus 5 is 3.
Did you get the same?
Yeah.
Like you have this fraction first and this one second? Yeah, it doesn't matter. Yeah. Good question. Okay, so I'm just going to give you one other kind of an exception. There's like that's the most straightforward type of problem where you just factor the bottom and everything's very nice and tidy. If you have something like this, and this is going to be a two-part, at least two-part lesson. I'm just going to show you this type of scenario. If you have a factor, this is already factored. We don't have to worry about factoring it. However, I have an x plus 2 the quantity cubed. If you have a factor of degree greater than 1, this has multiplicity 3, you have to assign an a to the x plus 2 cubed. Then you have to assign a b to x plus 2 squared, and then a c to x plus 2. You have to work your way all the way down. A letter is assigned to each of the factors going down. So if this was to the fourth, you'd need an a over to the fourth, b over the third, c over to the second, d over x plus 2. So if something's repeating like this 3 times, you have to do one for each of them. And I still need a d for my 2x plus 1. And you can see that it's going to get more complicated. The process is the same. We're still going to multiply both sides by this, which will eliminate that, and it'll divide off the left side. There we go. So we're going to multiply both sides by this, and we're going to have all sorts of different things over here, and you're going to have a system of equations bigger than just 2 equations and 2 unknowns. Okay, so if I was going to just start this one right here, 3x squared minus 2x minus, or plus 5, doesn't matter, over x cubed minus 2x squared. I was just going to start it. Why don't you try that? I'll give you 30 seconds to try it, or 1 minute to try it. All right, again, we're going to have, it'll test your factoring skills. How do I factor the bottom here? Can somebody tell me?
Probably not.
How do I factor this?
You take out
What do you take out?
x squared.
Very good. I'm left with x minus 2. Okay, that factors to be x squared times x minus 2. Now I need to assign an a to the x squared and a b to the x, because this is x. And we need one for the x minus 2. Okay, I think we'll pick up on that problem tomorrow.